Good afternoon, everyone. I want to present to you in here an application where we had to go in and choose some tools that were not catering for the regular purpose, but we wanted to choose tools for emerging communication technology. So this is an application for the emerging communications, and all of you know that the emerging communications are evolving very rapidly, and there is an ever increasing need for communication. All of you probably know it, that you want to download the movies and stream them, watch the everywhere video on mobile phones and PCs everywhere. So that's driving the need for more communication, and the bandwidth is very expensive commodity nowadays, and we can't create it. So that keeps the need for these emerging communication technologies to come up with higher and higher efficiency for the communication. So these technologies are competing as well. So we see the competition everywhere, both the wireless and wired communication. So we first identified what are these common trends in all these communications so that we can bring the tools to apply to them. And they're all very rapidly evolving, and all of them, almost all of them, we should say that, they're all based on OFDM technology. And they all consume wider bandwidths, very wide bandwidths, and then they need wide bandwidths for those kind of high data rates. And the higher order modulation is the key factor here. We need to keep up the high efficiency, so we need to go in and choose very high orders modulation. And another common characteristic in these communications is that they have intelligence built into that. So that's one thing that is making LTE successful today, and all the emerging future communications will need very high flexible frame structures. Both flexibility and adaptive frame structure is a must. And as I said, the higher orders of modulation lead to very low margins of signal to noise ratio. So we need to choose coding that can effectively pull the signal from the noise. So very robust coding is another characteristic that's there. And associated with the common technical trends, there are also common business trends that are associated with it. So either one has to compete or vanish from the scene because everybody is competing for it. And doing it first time, being in the market, being visible is very important. So you have to choose the proper tools for that. And the time to market, as I said, bringing the awareness that you have a product or service is very important. And then as one particular company leads the way, it has to keep up with not only improving the performance, but keep up reducing the cost. So you need a flow that allows you to reduce the cost of your overall cost of your system or the product. So the tools should provide you a flow for this. We'll go through all this as we go through the presentation. So if you were to go and then choose tools, if you look at around, for the particular application, when we looked at it, there were not many tools in the market that we can just go and then pick up and then use them. So we have to be very judicious about it. So the nature of the tools that we require have to be flexible, they have to be readily available, they have to be easily deployable and easily usable. And then the modeling and simulation is a very important part of the early choice of the selection of these tools. And mixing multiple domains in one simulation is a key characteristic of any communication emerging technology. For example, there's a lot of DSP involved, so you have to be in the numeric domain. You have to do your simulation in frequency domain, time domain, and then finally you have to link up to the hardware from the simulation to the hardware. So what we need is a very gradual transition from simulation to emulation to complete hardware testing to finally going into the manufacturing test. So we'll see a little bit more of this. The example that we have here, the application that we studied was DOCSIS 3.1. By the way, DOCSIS standards for digital data or cable service interface specification. So if you all use the internet at home or office through a cable, DOCSIS is already something that you are using. The existing standard is DOCSIS 3.0, and then 3.1 has come in. So why all this standard? Why this standard is coming? First of all, is because there is a lot of the fiber is providing, Google Fiber you might have heard, the Verizon is providing. So they're all already providing very high data rates, and the cable should compete with them. And in future, LTE is going to come and then provide a lot of high-speed data rates. So the DOCSIS 3.1, the goal is to provide a gigabit per second data. So be prepared. If you are a cable user, you may have it soon. And if the goals are, as I said, the gigabit downstream and gigabit upstream, and then we needed new techniques to meet the competitive challenges. And one of the challenges is that none of these emerging standards, you cannot have built a new infrastructure and throw away all the older infrastructure. You have to start looking at whether the new standard can be implemented on the older infrastructure. If you have followed through the 3G to 4G evolution, you might have seen that happening with intermediate stages. So these tools should support testing with the existing standard and also testing on the existing infrastructure. Going into the next slide, I have already talked most of this, so I'll just skip this one. And then the need at the time when we were looking at this catering for the needs of the DOCSIS 3.1 were doing it very quickly, and then the traditional simulation and instrumentation, like programming languages, it's always possible to start coding into a software, but that needs a lot of resources. And then so we have to create the waveforms, and then we have to create the analysis. So these two are the important pieces of the initial testing of any communication technology. So we looked at some of the tools that were available off the shelf. One of them is SystemVue with a feature called Flex OFDM. Because all these standards are based on OFDM, I'll go a little bit more details into that. And then the vector signal analysis is for doing the analysis once you create the waveform. And then it's no doubt the MATLAB is the engineering language widely accepted, so you should have some sort of linkage to that so that you can do a little bit of customization if needed as you start doing the testing. And then finally, you have to use the existing infrastructure. That means you're not going to go and then model the whole thing in software again. You should be able to link up your signals and analysis with the hardware that's already existing. So what pieces of hardware that can talk to the existing infrastructure is very important. So we looked at some of the box and the modular instruments. So I'll just briefly touch base on what these four tools are. SystemVue is a electronic system level designer, and it can do algorithmic development and then the DSP and RF in one platform. It can support communicating with MATLAB very seamlessly, and it can communicate with the analysis tools, the vector signal analysis software that I mentioned, and it communicates and then interactively talks to the instrumentation. So that's the most important part. And not least, it has a feature called OFDM library. I'll show you how easy it is to create a waveform. If you just know how to use the standard, if you understood the standard, it just takes probably a few hours to create a good waveform conforming to the standard. This is the analysis software piece. So a analysis software should understand what the waveform is, and once it knows the waveform, it can do measurements, all these measurements that are common to any communication standard that comes out. The modular instruments should have the characteristics of very high dynamic range, and they should be they should support very high data rates. So effectively what we are looking at is the very high ADC and DAC kind of components. So just a 1 second brief intro onto the OFDM. So a OFDM frame can have these characteristics. You can add preambles, you can have data. In fact, you can have on the data, you can have the pilot tones, and you can have additional data as well. So there is a payload, and then there is the preambles and pilots for decoding or understanding the frame. and these are all based on OFDM. So they usually have the idle or the guard bands, what we call, and the cyclic prefixes if you're ever used a OFDM. And the great example for OFDM success is the Wi-Fi. All of us use Wi-Fi everywhere, and the future Wi-Fi, future communication standards, everything is going to be OFDM. So the feature I talked in SystemVue has just 4 tabs. This feature comes with just 4 tabs, and then all that you have to do is go in and enter the parameters from your standard if you want to create a waveform. For example, if you can enter the center frequency and then the data rate, 204.8 megahertz for the DOCSIS standard, and then you can enter the DFT and then the guard carriers, the windowing. The windowing is done on all these waveforms. So these are all the basic top level characteristics that you can define, and in the next tab you can define any type of modulation. So it's very flexible in choosing what type of modulation we have to use for the waveform and for the data. And the next one is the pilot tones. So you can add pilots with any type of modulation here, and you can also define certain parameters so that you can choose the number of pilots, you can choose how they are spaced, and then you can choose how they vary from frame to frame. So it gives a lot of flexibility on how to choose these pilots. The last one is you have to be able to generate certain pieces of information that the analysis software will understand. So all the setup files required to be understood by the vector signal analysis software are automatically generated. Once you enter the parameters, you say click OK here, it is going to go and then generate the setup files that will be used by the vector signal analysis software. So once we create the waveform, we should be able to download into a very general purpose, very high performing sort of instrumentation. And 2 pieces that we identified, this is a very high speed with very broad specifications, or what we call the high speed. It has got a 14-bit 8 gigahertz or 12-bit 12 gigahertz kind of specification on the A to D converter. And then here is the digitizer with almost 8 gigabits per second. So you have huge bandwidths at your disposal that you can generate the waveforms. And the waveforms that we are talking for the DOCSIS are 192 megahertz if you are using a single carrier, or 384 megahertz if you are using 2 carriers. So that's the reason, that's the bandwidth available or that standard can use. That's the reason it is going to be able to do a multi-gigabit service, provide the multi-gigabit service. So when we put all these things together, we have the full solution with the software, with the very high level, very easy to use kind of interface, generates the waveform. You can download it. You can do a little bit of signal conditioning before giving it to the digitizer to provide the proper levels into the digitizer. And then finally it goes into the analysis software, and you should be able to make all sorts of measurements. The EVM, constellation measurements, PAPR, CCDF, both frequency domain and time domain measurements equally well. So once you are able to do that, this becomes such a unique and then very easy to create solution. In fact, we were able to create, when we encountered the need for DOCSIS 3.1, we were able to create in matter of hours a solution. So this solution was created, and we were able to study finally the waveforms, and then you can see that we could control the waveform skirt, and then we were able to get a very good EVM, and then the constellation for 4096, you can see that we were able to derive various measurements. That's the kind of performance we got. And finally, that's the, we used that. We were able to check the existing infrastructure with a particular vendor service provider, and we were able to find out how well this can fit into the existing infrastructure, how well this standard can coexist with the existing standard that they are already using. That's the end of my presentation. Any questions? If not, I let you leave whatever time left. Thank you very much.